Hello everyone. In this video I'm going to introduce you to Nock. Nock is the function at the heart of your Urbyte's virtual computer. If you don't already have Urbyte installed, you might want to go ahead and do that because I'm going to be working out some examples in the dojo, so if you want to try them yourself, you'll need to have that already installed. Okay, so Nock. You can think of Nock as being roughly analogous to assembly for your computer's processor. That's how it's referred to in a lot of the Urbyte documentation. But actually, I think this even possibly overstates how complicated Nock really is. Nock is very, very simple. Okay, so let's get to the details. What is this Nock function? Well, it's a Turing-complete function from a subject and a formula to a product. So the subject is data, and it has a certain structure to it. And the formula, you can think of that as being code which operates on or manipulates the subject, and the result of that manipulation is the product. Okay, so I mentioned that the subject has a certain structure to it, and so does the product actually. So it turns out that the subject and the product are nouns, and a noun can be one of two things. It's either an atom or a cell of nouns. So that second step is actually recursive, but we'll get to that in a minute. Okay, so first we need to talk about what an atom is. An atom is any unsigned integer, so 22, 3,497, and so on. All these are atoms. Notice that instead of using a comma to separate groups of 3 digits, we have a period. So this is German style notation here. And that's because periods are URL safe and commas aren't. Okay, so atoms are nouns, but cells are also nouns. A cell is an ordered pair of nouns, the left-hand side of which we call the head and the right-hand side of which we call the tail. So a cell can be a pair of atoms. It can be 12 and 13 inside those square brackets, or it could be a cell of cells, as we have in that second example, or it could be arbitrarily complex because it's recursively defined. So a cell of cells, and so on. You could also have something like a cell where the left-hand side's an atom, the right-hand side's a cell, and so forth. So these can be arbitrarily complex. The other thing to keep in mind is that cells, whenever you have some square brackets that are not there, that could be ambiguous in terms of what it might mean, since a cell is an ordered pair, but that's always resolved by aligning things to the right. So to see what I mean, let's go into Dojo and put in a few examples. So let's say I have this noun where I have 12, 13, 14, and 15. Okay, so this is a cell where the head is 12 and the tail is another cell. So if I put that in Dojo, it returns the same thing, except it strips out all the interior square brackets. And it does that because this is actually still the exact same cell. It's the same noun because everything is assumed to be aligned right. Alternatively, if I had input this cell, and entered that into the Dojo, the result is exactly the same thing with all the interior square brackets left in place. And the reason for that is if Dojo had removed some of those square brackets, that would be a different noun. Again, ambiguities are resolved by aligning to the right. Okay, so let's get back to the slides. All right, so we know that the subject is a noun. Well, it turns out that nouns are structured in a certain way. They're structured as trees. So if I have this as my subject, a cell where the head is a cell, 82 and 17, and the tail is a cell where the head is an atom, 34, and the tail is a cell of 52 and 74. If this is my subject, you could see the breakdown of this tree in this chart. We might want to refer to different parts of this subject, though. We might just want to take out certain pieces. So in order to be able to do that, we have to understand the address system. Okay, so it takes advantage of this tree structure. So we have like a tree-like address system where the top is just address 1. So if you want to refer to the entire subject, that's always at address 1. If you want to refer to the head of the subject, then whenever you're at a certain node and you want to know the address of the head, you just multiply your current address by 2. So the address right now we're at is address 1, so multiply by 2 to get the head, that's 2. And if I want to get the head of that, I multiply by 2 again to get 4, and that's the atom 82. So to pull out 82 from the subject, I want to refer to address 4. Now if you ever want to refer to the tail, so let's say we want to pull out the tail of address 2. In order to do that, you multiply by 2, so 2 times 2 is 4, plus 1 to get 5. So 17 from the subject is at address 5. So let's say we wanted to get the tail of the entire subject. So to do that, multiply 1 by 2 and then add 1. So 1 times 2 is 2, plus 1 is 3. And that pulls out the tail of the subject. To pull out the head of 3, multiply by 2 to get 6, and then plus 1 for the tail to get 7. And to get the head of 7, multiply by 2 to get 14, plus 1 to get 15 for the tail. And that's it. It's a pretty simple addressing system. Okay, so that's all I really have to say about the subject of the NOC function. So what about the formula? Okay, so the formula is described in the definition of the NOC Spec. So let's take a look at that. Let's go to the Urbyte website and take a look at the NOC Spec. So I'm going to scroll down a little bit. So it's important to note first that the NOC Spec is not actually written in the syntax of the NOC formula. This is a series of reduction rules that's described. These are reduction rules which describe NOC. This isn't NOC code itself. Okay, and if you don't understand the NOC Spec, that's okay. I'm not going to ask you to understand it in this video. I'm just going to highlight which parts of the NOC Spec we're going to cover in the next few minutes so that you'll be able to put together some small NOC codes and operate on the subject a little bit. Okay, so if you look here, I'll highlight this section. We'll talk about most of this here. So this series of reduction rules talks about NOC formulas 0 through 5. So today we're going to talk about NOC 0, 1, 3, 4, and 5. We're going to skip 2 for today. We'll cover that in another video. So NOC 0, this essentially is going to be a NOC formula that takes advantage of the address system. So NOC 0 just says, take out whatever is in the subject at address in. Okay. NOC 1 is a constant function, so it just says return whatever comes immediately after the 1. So if you just have a constant and you don't want to manipulate, or if you don't want to directly manipulate the subject to get something, you could use constant for that. NOC 3 tests whether or not something is a cell. It says yes if it is, no if it isn't. NOC 4 is increment. It takes an atom and then adds 1 to it. And NOC 5 is a test for equality. It takes 2 nouns and says whether or not they're the same. So we'll cover each of those and we'll learn how to make formulas that take advantage of each of those NOC functions in Dojo. And then one other line of the spec that we'll cover is this, and all this it really says is a pair of NOC formulas is also a NOC formula. Okay, but we'll cover all that with some examples in the Dojo. So let's get back there. Okay, so let's actually try out some formulas. But in order to do that, we're going to have to figure out how to input things so that the NOC function will operate in Dojo. So I'm going to have to teach you one Hoon rune to do that. The rune we want is .tar if you speak Urbyte, and if you don't speak Urbyte yet, then it's just period asterisk. And then inside parentheses, we're going to have to put the 2 parts, the 2 arguments of the NOC function. So we're going to have to give it a subject, and we're going to have to give it that formula. So for the subject, let's just give it the one that we've been playing with up until now. So the cell with 82 and 17, that cell in the head, and then the tail will be 34, 52, and 74. Okay, so that's the subject we'll work with. Okay, so now we have to put in our first NOC formula. So let's use NOC 0. I mentioned that NOC 0 uses the address system just to pull out a piece of the subject. So if I want to pull out the head of the subject, I'll just use NOC 2. Close my set of parentheses, and that gives me the head of the subject, 82 and 17 a cell of those two things. And that's exactly what I would expect from our example. So if I want to pull out the tail, I would just use NOC 3. If I want the head of the head, NOC 4. Or the tail of the head, NOC 5. And you notice that you can match all of these against that chart that we have in the top left corner of the video, and that's exactly what we saw when we worked out the examples. So I'll just do one more. Let's do address 14, and if you look at the chart at the top left, we would expect that to be 52, and indeed, that is what we get. Okay, so notice that in the chart we don't have anything at address 8. 8 would be the head of whatever's at address 4, but at address 4, all we have is an atom. We don't have a cell, so it doesn't have a head or a tail. So what happens if we put 8 in? Well, we get a crash. So just keep in mind that you have to use an address that actually has something there in the subject. Okay, so that's really all there is to NOC 0. It's that simple. Okay, so what about NOC 1? I mentioned this is constant. So constant, NOC 1 just says ignore the subject and return whatever is immediately to the right, whatever noun is immediately to the right. So I just have 8 to the right, so that should just return 8. It's that simple. What if I want 89? It just returns 89. And there, you don't have to have just an atom there, you can also have a cell to the right. So I can return a cell 89 and 17. Okay, so that's pretty simple. All right, so I mentioned that there's a rule in the NOC spec which says any pair of NOC formulas is also a NOC formula. So let's combine these two things that we have. Let's say I have NOC 1 and then 17 immediately follows, so that should just return 17, which it does. Now let's combine that with another NOC formula so that we have a pair of NOC formulas. So let's say 0, 2. So the pair of formulas I have is NOC 1 with 17 to the right, and then NOC 0 with 2 to the right. So this should return a pair of things now. It should return 17 at the head, and the result of whatever's at address 2 from the subject, that should be the right-hand side. And that is indeed what we get. We get 17 on the left, and then the pair of 82 and 17 to the right. Okay, so I guess I can make this a little more clear by not repeating numbers. So let's have 18 at the head, and then we have 82 and 17 to the right. Okay, so yeah, any pair of NOC formulas is also a NOC formula, and it'll just return the products of both as a cell. Okay, so that's NOC 0, 1, and also these pairs of NOC formulas. Okay, so let's try NOC 3. So remember, NOC 3 is a test to see whether something is a cell. So is the unsigned decimal 17, is that a cell? The answer is no, it's not, so I would expect this to return no. Instead, it returns a crash. So why is that? So it turns out that NOC 3 doesn't accept the thing you want to test. It must have a NOC formula immediately to its right, and the result of running that NOC formula against the subject, that's what it tests to see if it's a cell. So the cell 317, that's not a well-formed NOC formula. This is just a non-formula cell, or this is a non-formula noun. So this won't run correctly. It'll just crash on you. So if I wanted to see whether 17 is a cell, I have to embed that in a formula whose result is 17. Okay, so now that I've got NOC 1 in there, NOC 1, remember, is constant, so that should just return 17, and then 3 will tell me whether or not 17 is a cell. And indeed, it does say no. In NOC, 1 is no, and 0 is yes. Okay, so 17 is not a cell, neither is 22, neither is 23. Okay, so let's try something that is a cell. So I have the constant function which says, ignore the subject and return 22 or 23 and 22, that cell. And then NOC 3 is going to say whether or not that is a cell. And it returns 0 for yes. We can also combine this with NOC 0, we can pull out the head of the subject and see whether or not that is a cell. Yes, indeed it is, as we would expect since it's 82, 17 in a pair. Okay, so what if we want the head of the cell, the head of the subject? This should just, the head of the subject is just 82. That's at address 4, and we should expect that to be no, and indeed so it is. Okay, so that's NOC 3. That's all there is to it. Let's turn to NOC 4. NOC 4 is the increment function. It takes an atom and adds 1, or does it? So if I just put an atom to the right, it's actually just going to give me a crash. Okay, so that's strange. It's increment. It should just be adding 1, right? So it turns out that NOC 4 also needs a NOC formula immediately to its right. So if I want to test 17, or not test 17, if I want to add 1 to 17, I need to give it a formula whose result is 17. So I need to use a constant function, NOC 1, and then the result of this will be 17, and then that will be incremented. So now I should get 18. Okay, so I can knock 4 on 18 to get 19, and you can stack these NOC 4s, and that'll increment twice. You can stack it once more. Okay, I think I've beat that dead horse. Okay, so that's NOC 4. It's that easy. So let's talk about NOC 5. NOC 5 looks at the two things following it and says whether or not they're equal. So let's say I want to test whether or not 23 and 25 are equal, and I would expect that to be no. So I'm not even going to hit enter here. I'm just going to tell you this right here, what I have now, would be a crash because this is not a well-formed NOC formula. You have to follow NOC 5 with 2 NOC formulas, and it will test the result of those NOC formulas to see if they're equal. So if I want to test 23 against 25, I've got to use the constant function. Okay, now this will tell me whether or not 23 equals 25, and I would expect the result to be no, and it is. Okay, good. So if I want to test 23 against 23, I get yes. Okay, so let's pull out the 17 from the subject. So what's the address of 17 in the subject? So it's the tail of the head of the whole subject. Turns out that's at address 5. So that's 17. So I'm going to test that against 17. So this is sort of a way to test to see whether or not I really did calculate that address correctly to see if I am pulling out 17 from the subject, because I'm going to test and see if that's equal to the constant 17. And yes, it is. Okay, so I got a positive result there. If I'd put 18 here instead, that would be no. Okay, so I've only compared atoms with this function with NOC 5, but you can also compare cells. So one way to do that, I can compare the head of the whole subject, which is the cell 8217. I can compare that against the atom 18. Of course, you know that a cell is never equal to an atom. They're different nouns, so that should be 1. Okay, but let's actually put 82 and 17 in here, and that returns yes. Okay, so I think that's enough for today. Thanks for watching. There will be more NOC videos that will teach you the rest of the NOC function. You should definitely check those out.